Section 11.6, plane curves and parametric equations. Alright, so they're saying let f and g be functions of t over an interval I. Then a set of points defined by x is f of t, y is g of t is called a plane curve. The equations x is equal to f of t, y is equal to g of t are called parametric equations curve, and t is called a parameter. Alright, so where does this come in? This comes into play like, let's say that I throw a baseball or something, okay? And I want to know its horizontal position and its vertical position, okay? So maybe it has a horizontal position here, this much, and maybe it has a vertical position like that. Maybe it has a horizontal and vertical position. Maybe we'll graph it out, it looks something like this, okay? Then eventually it's going to fall to the ground, right? It's going to fall, it's going to hit the ground right here. Well, what I want to do now is I want to determine, okay, where's it at 3 seconds or whatever, okay? Well, here was what? A horizontal position of, let's say, 1 and a vertical position of, say, 4 right here, okay? But that was at 0 seconds, right when it released my hand. How about after 1 second? Maybe it's up here. After 2 seconds, it's here. Because x and y are the what? Horizontal and vertical position of it. All right, anyway, let's sketch some curves given by these parametric equations. So let's see. First way we're gonna sketch a curve is we're gonna plot points. Our first example here is sketch the plane curve by plotting points. Indicate the orientation of the curve. And they give us x is equal to t squared minus 4 and y is equal to t minus 1. And then they say for t is between -2 and 2, including -2. Alright, so that's my x position given by that function. This is my y position given by that function, okay? So I'm going to start out by plotting points. I'm going to make a chart with t, with x, and with y in it, okay? And I'm going to pick a value of t and calculate x and y. Let's see, let's pick a value of t maybe at -2, okay? When t is -2, sub it in here, what do I get? 4 minus 4 is 0 for my x value. How about my y value? What is that? -2 minus 1 is -3. Let's pick another t value, say -1, okay? When t is -1, we have -1 squared minus 4 is -3 for my x. And my y value is going to be what? -1 minus 1 or -2. We could keep doing this. 0, if I have a t value of 0, sub it in here, x is in -4. And y is -1, t value of 1. What do I have for x? -3. What do I have for y? -2. And a t value of 2. Now I'm going to put a star by this one, okay? Because I can go up next to 2, but I cannot include 2 because there's no equal sign there. Alright, so that's why I put the asterisk to know to look out for something right there. If that's 2, a t value of 2, so I have 4 minus 4 is 0 for my x value. And how about here? What's 2 minus 1? That'd be 1, right? Now let's draw this. Let's draw this curve by plotting the x and the y values, okay? Now maybe I'll go 1, 2, 3, 4, call that 4. 1, 2, 3, 4, call that 4. -1, 2, 3, 4, call that -4, and 1, 2, 3, 4, call that -4, okay? Alright, so let's plot these points and draw this curve. Let's see, maybe I'll pick another color. Alright, so xy is what? 0, -3. 0, -3 is right here. This point will be what? X coordinate -3. Y coordinate -2. So plot -3, -2. How about -4, -1? -4, -1. Let me erase this, get it out of the way. -4, -1. Then we have -3, -2, -3. Oh, this point must be wrong, right? Let's see. So what happens whenever I plug in 1? I get what? -3. Yeah. What happens when I plug in 1? I get what? 0, right? Change that one to 0. All right, so I have -3, 0. It's right there. And then what? 0, 1. 0, 1. Now, remember this one I have what? An asterisk by it because I do not include that t value. So 0, 1 is going to be like an open circle. Now, this thing, whenever we plotted it, this curve, we would get a curve that looks something like that, like a sideways parabola almost, okay? But it has endpoints. Now, they want us to, with these parametric curves, they want us to go ahead and put the direction that they're moving in, okay? So this one, what happened when t was -2? We got the point 0, -3. What happens when t is -1? We get the point -3, -2, right? So this curve is going this way, and then what happens here? Then it continues going like that way, okay? It goes like this. So we put little arrows on it to indicate the direction that it's moving with time. All right, so that's a way of graphing these with plotting points. Let's look at something called eliminating the parameter. What was the parameter? Remember the parameter was t. All right, your book says sometimes we can use this to get an equation in terms of x and y. So in other words, where we get rid of the t, so it's something familiar to us with just x and y, like y is equal to x squared plus 1 maybe. And you know that was a parabola, okay? Now we have to be careful when we do this because we got to look at restrictions. Let's see. Let's do our next example here. Erase all this stuff. And let's see. Sketch the curve and indicate its orientation. So what they mean by that is they want you to indicate which direction it's moving, like the other one's moving that way. So we have x is equal to t plus 2. Then we have y is given by t over t plus 2. Okay, so they want me to sketch this curve. Now I'm going to try to eliminate the parameter t here, okay? But I need to make some observations here. Actually, let me, no, they don't give me any particular t values, restrictions. All right, so right here, t cannot be -2 because that'll make this undefined, right? So t cannot be -2. All right. Now, what does that mean that x cannot be? If t can't be -2, -2 plus 2 is what? 0. And x is 0 when t is -2. So this means that x cannot be equal to 0. So we got to look out for those, okay? We got to keep that in the back of our head. All right, to eliminate the parameter now, what we do, so we take one of the equations and solve it for t. Like I'm going to take this one. It's going to be much easier to solve for t than that one. So I have x minus 2 is equal to t. Now I take the other equation, and where I see my t values, I'm going to sub in x minus 2. So y is equal to x minus 2, subbing in for t, right? Over x minus 2 plus 2, because I'm, what? Substituting in for t. So y is x minus 2 over, what happens here? I just get x, right? All right, now let's go ahead and graph this equation. We got it in terms of x's and y's. Let's graph this equation. We know that's a rational function, right? What else do we know about that rational function there? We know that it has a vertical asymptote. Gonna get my marker to right. At x is equal to 0, right? We know we have a horizontal asymptote when y is equal to 1. So let's go ahead and draw that stuff, okay? X is equal to 0 is right here. Y is equal to 1, we can say it's up here. Y is equal to 1. And let's plot a few points to see where this rational function goes. Remember, it's going to go either here, or it's going to go right here, and then the other part's going to go here, or it's going to go right here. Well, let's see. What happens whenever x is, say, 1, okay? When x is 1, we have 1 minus 2, or negative 1, over 1, so we get out what? Negative 1. So whenever x is 1, y is negative 1. How about when x is 2? When x is 2, we have what? 2 minus 2 is 0 over 2, or what? 0. So we have 2 comma 0, and this portion of my graph is going to do something like this. All right, what about this portion of my graph? Let me see where I'm at. Am I up here, or am I down here? Well, let's pick an x value of negative 1. If I pick an x value of negative 1, what do I have? Negative 1 minus 2 over negative 1. So what does that give me? Negative 3 over negative 1, or positive 3, right? So I'll give me negative 1, positive 3. How about when x is negative 2? What do I get? We'll sub in negative 2 here and here. So you get negative 2 minus 2 over negative 2, or negative 4 over negative 2, or what? 2. So we get negative 2. We're up here at what? 2. So what does my graph do? Does something like that, right? Now technically, let me not put arrows on these ends right here, okay? Because I want to put what? How the graph moves. Which direction does it move in according to my time parameter? And if I put multiple arrows, that's going to confuse me. But before we get into that, let's look at this. We said that t could not be equal to negative 2 meant that x cannot be 0. Let's try to take out our x being 0. Well, if we look at this graph, I never take on an x value of 0 because of that vertical asymptote, right? Now, which way is my graph moving according to my time parameter? Let's see. Let's think about this for a second. When time is, say, I don't know, pick a value. When time is, say, 1, okay? What do you have? Y is equal to 1 over 1 plus 2, right? So y is equal to what? 1/3? Where's x at when time is 1? X will be 1 plus 2, or what? 3, right? So that gives me a point 3. 1/3 is where I'm at a time value of what? 1. Okay? But that doesn't tell me which way it's moving. Is it moving this way, or is it moving that way? Okay? Let's try a time value of, say, 2. When t is equal to 2, what do we get? Well, what do we get for x? X will be 2 plus 2, or x is equal to 4. And what will y be when t is 2? 2 over 2 plus 2, or y is equal to what? 1/2, right? So what does this give me? This gives me the point 4 comma 1/2. All right, when t was 1, I was at what? 3 comma 1/3. Whenever time is 2, I'm at where? 4 1/2. So I must be moving this way along my curve, right? And you could do the same thing for this curve right here. Pick a value of t, like say -4, pick a value of t, say -5, -3, and you'll end up getting where it moves that way. And just mark it with those little arrows.